Welcome back to the deep dive. It is February 13th, 2026. And if you've been tracking the hardware space at all, you know the vibe has shifted.
Oh, absolutely.
For the past couple of years, it really felt like software was writing checks that the hardware just couldn't cash. We had these huge AI models, 8K video, but our silicon was just sweating.
It's been a total bottleneck era, hasn't it?
Yeah.
We spent so much time talking about optimization, doing more with less, because the raw power just wasn't keeping up.
But it feels like the hardware is finally punching back. We're looking at an article today from Power Digital Media. It's called AMD's 2026 Innovations, Unpacking the Future of Compute. And honestly, some of these specs, they look like typos.
They definitely make you do a double take.
So today we're going to break down the new Ryzen 9950X3D2, which is a mouthful.
Laughing slightly, it is.
Yeah, this Medusa Halo APU. But our mission here isn't to just read a spec sheet. We need to figure out if this stuff actually matters for you, for the developers and creators listening. Is this a real leap or just another 10% faster for 10% more money?
And that's always the question. But I think looking at the architectural changes here, especially around memory, this feels different. This isn't just a clock speed bump. It's a fundamental change in how data moves.
Okay, so let's start there. The thing that confused me most was the Medusa Halo. It sounds like a super weapon from a comic book.
Right.
But the article says it's a flagship APU, and its main feature is LPDDR6 RAM.
Yep.
And LP is low power, right? We see that in ultrabooks and tablets. Why would they put laptop RAM in a high-performance desktop part? It sounds like a downgrade.
It does sound counterintuitive, I get it, if you're used to the old way where desktop RAM means these big sticks you slot in yourself. But the LP part, it's kind of evolved. It's not just about power saving anymore. It's really about signal integrity.
Signal integrity? What do you mean?
Well, think about a normal motherboard. You've got CPU here and then these copper traces running all the way across the board to the RAM slots.
Yeah.
That physical distance creates electrical noise. It just limits how fast you can reliably push the data. With LPDDR6, it's soldered right on the package, right next to the processor. The traces are incredibly short.
So you're trading the ability to swap out your RAM for pure speed.
You are trading modularity for a massive increase in bandwidth. The source actually cites a Tom's hardware report, and it claims up to an 80% increase in memory bandwidth over, a standard DDR5 setup.
80%. Come on. That sounds like marketing fluff. When we go from DDR4 to DDR5, we're talking, what, 15, 20%?
I know. It's not about the speed of the cards, though.
Yeah.
It's like they've added 20 more lanes to the highway. By getting rid of the DIMM slot, you can run a much, much wider memory interface. For browsing the web, it doesn't matter. But for the people this is aimed at, AI, video, it's everything.
Okay, so let's talk about that why. Why is bandwidth the big deal here, more so than just raw clock speed?
Okay, imagine your CPU is the world's fastest mathematician, solves any problem in a nanosecond. But the problems are written on bits of paper in a warehouse down the street. It doesn't matter how fast your mathematician is if he's always waiting for the delivery truck.
And the LPDDR6 is like a pneumatic tube straight to his desk.
Exactly. It's a fire hose of data. And in 2026, we're not just processing lines of code. We're processing massive data sets, AI training, scrubbing an 8K timeline. That stuff chews through RAM. If that pipe is too narrow, the whole system just hangs. That 80% means the processor is never waiting. It's just always crunching.
But there has to be a catch. If it's soldered on, I buy a board with 32 gigs. I'm stuck with 32 gigs forever. No upgrades.
That is the trade-off. It's sort of the consolification of the PC, right? You get this incredible optimized performance, but you lose that ability to tinker. For a professional workstation, though, where stability and throughput literally equal money, I think a lot of pros would make that trade.
I guess if the baseline is high enough, maybe you don't need to upgrade. If they're selling these with, say, 64 or 128 gigs standard.
Precisely. But it was a moot point. And the source mentions latency, too. System responsiveness.
Yeah.
That's key. It's not just about the big render finishing faster. It's about the micro stutters.
Oh, the micro stutter. The absolute bane of my existence.
Right. You're just dragging a window, and it freezes for a split second. That's usually the CPU waiting for data from RAM. At these kinds of bandwidths, that latency basically disappears. The whole computer feels like it's one step ahead of you.
Okay, so Medusa Halo is the data highway. Let's look at the engine. The article spends a lot of time on the Ryzen 9950X3D2.
The naming conventions are just getting longer and longer.
I know. But the rumors they reference from Tech Power Up, they're calling it the new heavyweight champion. Higher clocks, more cores, the usual stuff. But that 3D2 part, That implies a second generation of their 3D V cache.
And this is where enthusiasts should really be paying attention.
So we know cache is super fast memory right on the chip. Why is this version a big deal? Is it just more of it?
More is part of it, yes, but it's about how it's implemented. In the first generation, that 3D cache was really sensitive to heat. It was stacked right on top of the core, so it acted like a thermal blanket, trapped all the heat in.
Right, so you had to choose. You could have the big cache for gaming, or you could have the high clock speeds for, like, compiling code. You couldn't have both.
Exactly. The 3D2 suggests they've solved that problem. Maybe it's a new manufacturing process, maybe they've improved the interconnects. Whatever it is, the source talks about uncompromised multitasking. And that phrase suggests we finally get the best of both worlds. High frequency and massive cache together.
I want to drill down on that multitasking idea. Every CPU maker claims that. But what does it actually mean for someone listening who's got a compile running, a video rendering, and Slack open? What actually changes for them?
It comes down to something called instruction pacing. When you have a massive cache, the CPU almost never has to go out to the slow system RAM. It keeps the working set for all your apps right there on the die. So when the CPU has to switch from your compiler to your music back to the render, that context switch is instant.
So no more mouse lag while I'm rendering.
In theory, yes. That horrible chugging when
Yeah.
your mouse cursor feels like it's moving at 15 frames per second, that's a cache miss storm. The CPU is just thrashing trying to pull data for 3 different things at once. If the cache is big enough to hold all 3, the chugging just stops.
That is the actual dream. Okay, so Power Digital Media also proposed a dream build for 2026. And this is why I got a little confused.
The Workstation build, yeah.
They pair this brand new cutting-edge Ryzen CPU with an MSI Supreme X RTX 4090.
I noticed that too. It's an interesting choice.
It's February 2026. That card came out in late 2022. It's almost 3.5 years old. Why would a Future of Compute article recommend a GPU that's practically a senior citizen? Why not the 5090 or whatever's current?
It seems weird on the surface, but if you think about it from a workstation perspective, it actually makes perfect sense.
Okay, how?
2 big reasons. First, driver maturity. By 2026, the drivers for the 4090 are going to be absolutely bulletproof. If you're an editor working on an 8K project, you can't afford crashes. You don't want to be a beta tester for brand new 50 series drivers. You want stability.
Okay, stability. I can buy that. What's the second reason?
VRAM. The 4090 launched with 24 gigabytes of VRAM. That is still a huge amount. Unless the 50 series comes out with, say, 48 gigs at a consumer price point, which is super unlikely, the 4090 is still the price to performance king for these heavy memory-intensive workloads. It's old as reliable.
That's a really good point. It's not about the highest benchmark. It's about whether DaVinci Resolve crashes mid-render. And the article specifically calls out 8K video editing here.
Exactly. And 8K is just brutal on hardware.
Yeah.
To scrub through that footage smoothly, you need that massive VRAM buffer and the parallel processing power. But you also have to feed that GPU, which brings us to the storage they picked.
The Samsung 990 Pro 4TB. Again, a drive that's been out for a while. But they specifically mentioned managing large code bases, and I love this, rapid NPM install cycles.
Laughs. The developer trauma is real.
It really is. You type npm install, and then you go for a 10-minute walk while it downloads half the internet.
It's not just the download, though. It's the file structure.
Oh.
A Node modules folder can have, what, hundreds of thousands of tiny little 1 kilobyte files. A cheap SSD just chokes on that. It's great at reading one big video file, but ask it to handle 100,000 tiny files. It just struggles.
It's the random read-write speeds, the IOPS.
Precisely. And the 990 Pro is legendary for its random I/O performance. For a developer, that means unzipping and writing all those tiny files happens in seconds, not minutes. It keeps you in the flow state. You're not getting distracted waiting for your packages to install.
So we have the bandwidth from Medusa Halo, the cache from the Ryzen chip, the raw power from the 4090, and the IOPS from the Samsung drive. It's a balanced system.
It is. It's a system designed to eliminate the bottleneck at every single stage of the process.
And there's always a but. Hardware is just a very expensive paperweight without the right software. The article pivots here to what it calls the software equation.
Which is critical.
Yeah.
It's like having a Ferrari engine, but you're running it on bicycle tires.
They call out specific architectures needed to use this power. Next.js 16 Plus and Node.js 24 Plus out.
This is a huge deal because for so long, JavaScript and Node were famously single-threaded. You had one core doing all the work and the other 15 cores on your fancy CPU were just sitting there, watching.
So buying a 16-core chip was basically a waste for a lot of web developers.
For running the app itself, pretty much, yeah. But Node.js 10.4 Plus implies a huge change in the runtime. We're probably seeing much better native support for things like worker threads and parallel processing.
Okay, so what does that actually mean?
It means the software is finally smart enough to chop up the work. Instead of one core trying to build your whole project, Node 24 can split that job into 12 pieces and give one piece to each core of that Ryzen 9950X3D2.
So a 30-second compile time could drop down to, what, 2 or 3 seconds?
Ideally, yeah. It turns a wait-for-it moment into an instant blink. Which leads to the most interesting part of this whole report, local LLM integration.
The buzzword of the decade, large language models. But we think of ChatGPT, something running in a giant data center somewhere. The source is saying we should be running these things locally, on our own machines.
And that's where all this hardware finally pays off. To run a decent LLM, something smart enough to help you code, you need two things: a ton of VRAM and a ton of memory bandwidth.
Why the VRAM specifically?
The model itself, all those billions of parameters, has to live somewhere fast. If you try to run it off your SSD, you'll get like 1 word a minute, has to be loaded into memory. With the 24 gigs on that 4090 and the fast system RAM from the Medusa Halo, you can load a really powerful model entirely into memory.
So I can basically have a ChatGPT level brain living inside my desktop computer.
Exactly. And that changes absolutely everything for privacy and security.
That's the big one for me. I can't just paste my client's proprietary code into a public chatbot online. I'd be fired on the spot.
You would. But if the model is running locally, you can feed it your entire code base. You can say, hey, refactor this top secret project, and not a single byte of your data ever leaves your machine. It's completely secure.
And no subscription fees.
No fees, no internet lag, no server queues. The response is instant. It's as fast as your hardware can generate it.
The article also mentions seamless containerization. How does a local AI help with something like Docker?
It's all about optimization. A local AI can look at your code in your Docker file and say, hey, your final container is 2 gigabytes, but you're only using these 3 libraries. I can rewrite this file for you so the container is only 50 megabytes. It can optimize your entire build pipeline in real time.
It's like having a senior DevOps engineer living inside your CTU.
That's a perfect way to put it. It's a force multiplier for individual developers and small teams.
So zooming out, we've got the bandwidth, the cache, this balanced workstation build. The theme really seems to be about removing friction.
It is. It's about getting rid of the waiting. For so long, the friction has been the hardware. We've been waiting on render bars, waiting on compiles, waiting on API calls to the cloud.
And this 2026 AMD lineup is basically saying the waiting is over.
They're targeting the bottleneck itself.
Yeah.
They aren't just giving us higher frame rates in games, they're giving us our time back. And for a professional, time is the only metric that really matters.
It does raise a really provocative question, though. For the past decade, we've moved everything to the cloud. Cloud storage, cloud AI, cloud computing.
Yeah.
But if I can build a workstation with this 9950X3D2 and a 4090, and it can run an 8K workflow and a huge AI model all by itself, are we about to see the pendulum swing back?
The personal data center.
Exactly. If the box under my desk is more powerful and way more private than a cloud service, why would I even use the cloud for development and creative work anymore?
It really makes you wonder about the business models of the big cloud providers. If every developer has a rig this powerful, do we need to spin up cloud instances just for testing? Maybe not.
It feels like a return to the personal in personal computing. Except this time, the personal computer is a genuine supercomputer.
And that just lowers the barrier to entry for everyone. If you can render a Pixar-quality short film in your bedroom, the gap between a huge studio and an indie creator gets a whole lot smaller.
That's a fascinating thought to end on. The hardware isn't just getting faster, it might actually be changing who gets to create the future.
It's incredibly empowering.
We'd love to hear what you think. Are you ready to solder your RAM to the motherboard for an 80% speed boost? Or are you clutching your dim sticks for dear life? Let us know.
Thanks for listening to The Deep Dive.
Keep building.